This is our model number 557, IoT based, IoT meaning Internet of Things based electricity energy meter reading through Internet. Energy meter reading is conveyed over the Internet upon a dedicated web page for display on graphical format under IoT. We will see those graphical format, but before that let us try to understand how the circuit setup is made. We have an energy meter, and the energy meter, as we see, it has got 3200 impressions. That means 3200 blinking of this LED for 1 unit. 1 unit means 1 kilowatt hour. 1 kilowatt hour is 1 unit. This is a single phase meter. Then we have a load here. We connect a load here, and based on the load, this will be blinking at the rate of 3200 impressions per kilowatt. Since we will be putting a 100 watt lamp here, and 100 watt lamp will take 10 hours to become 1000 watt hour. 1000 watt hour means 1 kilowatt hour, and we have to wait for 10 hours for this lamp to operate to get this 1 unit reading. So for that, what we have done, we have made some other arrangements. We will look into that. Then we have a microcontroller, then we have a RS-232 interface, MAX32, and then of course a LCD for display. Then we have a GSM modem here, which is built in with a SIM that has got data connectivity. That means it can go through the internet. You need not have to pay for the SMS, but it will work on the internet setup. And as far as the blinking, sensing this blinking, which is responsible for the load, we have an LDR arrangement, and then in fact this LDR will go here to sense the blinking. But since, as we discussed, will take a long time, so we will take care of the blinking of the GSM modem was to just for a demonstration purpose as to how many units are being consumed here. So once we switch on, what we notice is the energy meter on the web, testing GSM takes place, then initialization of the GPRS takes place, and this all goes on continuously once we switch on, and then it takes little bit of time for it to stabilize. As far as the initialization is concerned, the data connectivity is made. What we can notice by this blinking green LED, the blinking green LED establishes the connection, and it's now connecting. Now initially it finds 0, 0, 0, 0. That is, the unit is 0 and rupees is 0. As we have said that instead of taking the blinking pulse from here, we will take these blinking pulses, which will help us to we'll take these blinking pulses so that we can see the reading much faster, and since the same thing, the blinking will be coming here once we put the load here. Since we have not put the load, we don't find any blinking on the meter. Now what we notice, now once this blinking, now we find that, so what we have taken, this is as 1 unit and this is as 1 rupee, in order to see the good improvement. So what we find, now the cost is this much as per the unit cost that we have programmed, and the unit is this much consumed. So as we go on consuming the power, that means the blinking what we had seen, as the blinking goes on increasing, what we will notice, this unit consumption also goes up, and the cost accordingly also goes up. Every 10 to 20 seconds we have set for the data to be changing. Now you can see the data has changed to 0.05625. And this also has become 0.00937 units. The data is already connected, and then it goes on changing based on every time that is being programmed, and based on which this data will be sent to the internet, which we will see in the graphical format in the computer system. As we have discussed, it shows very little. It's just because 3200 pulses are required for making it 1 unit. That is how we have to wait either for that much of time for consuming 1 unit, or we have to see in this decimal format of the unit consumed and the price thereupon. And simultaneously this also changes. What you can see in the chart format also, you'll see the date time is also changing. Now it sends this data, and again after certain time it will show the other data. It will continuously go on showing this data, and which we can see on the internet.